Here's more on solving exponential equations. Number 3. 4 is being raised to the 3x plus 5 power, and it's equal to 16. Again, we want to make sure that we have a common base. I'm looking at the base over here, which is 4, and I'm thinking, is there a way of me expressing 16 in a different way that utilizes that same base? And we can. We can use 4 squared instead of 16 and bring down the left side of the equal sign or the equation as is. Since they have the same base or a common base, we could utilize exponent properties. They have the same base, so we can compare the exponents, and we're going to bring those down as a new equation, which is going to take the form of a linear equation that we used to working with. And we're going to isolate x. And we did that first step by taking away 5 from both sides of the equation. And now we want to undo the multiplication that's happening here by dividing by the 3, which was in front of the x, the coefficient, making x equal to -1, which is your solution. And it's always a good idea to check rewrite the original equation, and then our answer is going to be substituted. So x equals -1. 4 is raised to the 3. Instead of putting x, I'm going to use parentheses and put -1 for x, add 5 on, and that's all part of the power, which is in the superscript, and this is equal to 16. 4 to the, and then we're going to simplify the power up here. -3 plus 5 would be a 2. If we square 4, we do get 16. Therefore, we have the right answer here. Fourth example or exercise. Eight is raised to the 2x power, and it is equal to 2 to the x plus 5 power. Again, we want to utilize that idea of a common base. So we're going to look at our current bases, 8 and 2, and think if we could use a common base. 2 is a pretty small number, so let's think about 8. Can we express 8 in a different way? Yes, we can. We can, and using exponents, this is. We could express it as 2 cubed. So I'm going to trade that out. I'm going to use parentheses to group that together. I'm going to trade out the 8 and substitute it with 2 to the 3rd power. That's still raised to the 2x power, which is equal to 2 to the x plus 5 power. And then we're going to use exponent properties to simplify. We're going to use the power rule here because we have a power raised to a power. We can keep the base as 2 and multiply these powers to become 6x. Again, that's in the superscript. It should not be on the same line as the base, nor should it be multiplied by it. We can't make this a 12x because that's not multiplication happening. So we're going to leave it as 2 raised to the 6x power. And over here, we have 2 raised to the x plus 5 power. We have our common bases now, so we can drop the exponents and then solve. And we would like to move all the x terms to one side, so I'm going to subtract the x from both sides. 5x is going to be equal to 5. Divide by 5. X is equal to 1 as your solution. And we want to check our answer. Original equation. 8 is raised to the 2x power is equal to 2 to the x plus 5 power. We're going to make our substitution of the answer or the solution. this is going to come out as 8 squared. Over here is going to be 2 to the 6th power. 8 squared is 64. And 2 to the 6th power is also the same. If that didn't come as naturally with mental math, you could of course use your calculator and verify that. So our solution is correct. If the check wasn't to work out, we would know that there was something wrong with the work. And our last classwork exercise was the 5th one. And that was solving for x. We're finding the solution. 16 is raised to the x plus 4 power equals 32 is the base, and it's raised to the following power, 2x minus 10. Look at your current bases, and we want to find a common base that we could use. And if you look at 16, the first thought to use might be 4 squared. But then you have to think if you can express 32 using that same base of 4. And that's not the case. So you have to think a little bit deeper. And then you'll realize how the better choice would be to use 2. We know that 16 is 4 squared. So 4 is the same as 2 squared. And if we square that, it would be 2 to the 4th power. And you could verify this on your calculator. 2, you could also use trial and error. We know that we want to use a base of 2. 2 to the 4th power is 16. And we want to express 32 using the base of 2. And the one that would work would be 2 to the 5th power. We could verify. It will work out. And then we are going to enclose those in parentheses and then drop down the power that was existing already. Again, keeping it as a superscript. We're going to use the power rule. The base stays 2, and these are going to be multiplied. We're going to multiply the 4 by the x plus 4, which is going to come out to be 4x plus 16 in your superscript or your power. 2 is raised to the 4x plus 16 over here. Again, a power to a power, so we're going to multiply the powers, keep the base. 5 is multiplied by 2x minus 10, distribute in the superscript. And that's going to be, in the superscript over here, it's going to be a 10x minus 50. Same base, so now we're going to work on finding x using the exponents. I'll rewrite this up here so I get more space. Again, we have the same base of 2, so the bases can be dropped, and then the superscripts or the exponents, the powers, can be set into a linear equation. And we're going to subtract 10x from both sides in order to move all the variable terms to the left side. This is going to come out to be negative 5x. I'm sorry, my apologies, negative 6x. 4 minus 10, negative 6x. Plus 16 equals negative 50. And then we're going to move the constants to the right side by subtracting 16 from both sides. Negative 6x is equal to a negative 66. divide each side by -6. X is equal to 66 over 6. X is equal to 11. And it's a good idea to check. Original equation. And we're going to substitute x equals 11. 4 times 11 is 44 plus 16, 60. So 2 is raised to the 60th power, and let's see if it's equal to 2. And then the power here would be 10 times 11, 120. 111, excuse me, minus 50, which would be 60, which is an identity. So that answer does work. That is the solution. X equals 11. And those are the solutions to the classwork on exponential equations.